Okay, so in the last class, I had given you a food for thought to think about fan as a control system. And when we discuss fan, actually that will lead us to a very interesting classification of automatic control systems. Till now, I think we have discussed two examples. One was single degree of freedom system, and the other was the air conditioning system. And third example that I am now going to consider is fan. So fan stands out from these two. In what way? We'll just now see. The example of fan. So when you would be thinking about fan, you would say, sir, that there is of course a system that I am trying to control. So system box is ticked, right? Then I said that in a control system, the other components are sensor, right? So I don't know whether it has a sensor or not. So maybe cross, maybe right, we'll see. Does it have an actuator? Well, it does have an actuator. It has a motor which rotates. Right? So it has an actuator. Right? Do we have a reference value for it? I don't think we set any reference value in a fan, right? We don't have the option of setting a reference value. Does it have a controller? Well, it depends upon what is the system, how you define the system here. Okay. So let me go into detail. If I look at fan in isolation, right, I'll just explain you what do I mean by in isolation. That just fan working over your heads. If I just look at it, it will still be a control system whose speed you can control, right? But it is a system where you do not take any feedback from the system. The main component sensor here is absent. This component is absent. There is no sensor in the system. When there is no sensor in the system, that means that you are not sensing the control variable throughout the process. When you are not sensing control variable throughout the process, the question of comparing it with the reference does not arise. Right? So, if I would like to draw the feedback, if I would like to draw the block diagram for such a system, what would it look like? It would just be a system, right? There would be its output, which is not going back, right? Which is not being sensed. This is the output of the system. Right? But there is a controller, right? You are the controller who controls it. You operate the knob, which goes to the actuator and which ultimately goes to the system. There is no reference, right? There is some actuator in between. So what is happening here is this loop is not getting closed. These are some of the jargons of control system technology. The loop here is not getting closed. Therefore, such a system is classified as or is categorized as open loop control system. The two cases that we discussed in the previous videos, that was single degree of freedom system and air conditioners, were examples of, these were examples of closed loop control system. These were the examples of closed loop. So let me discuss this two in detail. Let me now go away from fan. Even as I said, if you take fan in isolation, it becomes an open loop system. But if you take fan and the human being who is operating the fan, you might want to think it as a closed loop system. How? What is the sensor? Sensor is our sense of airflow in the room, right? We are sensing the airflow in the room. And as soon as we sense, and we have a reference also, we want the airflow to meet our expectation, right? We have a reference in our minds. Right? So we become the controller also, we become the sensor also. We also have the reference in our minds, and we are the controller. We decide upon the control action. We decide whether I want to increase the fan speed or I want to decrease the fan speed. And then we also are in a sense actuator. We apply the control action. Right? So if you take fan plus the human being operating it, then it becomes a closed loop system. But fan in isolation is an open loop system. Right? So that is what I meant when I said fan in isolation. In itself, it's an open loop system. Right? There is no sensor in it. But when you take your own self as a part of the system, in the system definition you include your own self, then it might be classified as a closed loop system. Now let us see in detail these two systems, because these are two very important classifications of control system. What are the other examples of open loop system? What can be other examples, classical examples of open loop system, and then we'll see how can we make it closed loop system. Right? So one of the most classical examples of open loop system is your washing machines, which are, of course, I am talking about the non-automatic washing machines. Right? What happens? Why is it an open loop system? It is an open loop system because the washing machine, the simple washing machines which are not automatic, what they do, you set it for some time to work. Let's say you set it for 15 minutes, you set it for 20 minutes. It would keep on running for that much amount of time, and then it would stop. Right? The washing machine does not have a sensor in it. The one washing machine we are talking about. And it does not have a sensor, so it does not senses whether the clothes have been washed to a particular degree or not. So it does not have a reference point also, what is the degree of washing. So they can be classified as open loop system. You just give the command and it follows it. It is not smart in that way. How can you make it a closed loop system? Well, if you have a sensor in the washing machine which senses the quality of water inside the machine, and when it sees that the water is clean enough after some amount of washing, it senses the quality of drain water or the water inside the machine and decides upon the appropriate control action. For example, it decides that if the machine requires more detergent powder, so it sucks in more detergent and puts into the machine. Or if it decides that detergent is not required, only some more spinning of clothes is required. If you devise any such system, then this washing machine actually becomes a closed loop system. So you see that the important component of closed loop control systems are the sensing of the control variable, and that sensed value is compared with a preset reference, and that is absent in the open loop system. That is only present in the closed loop system. And how we can convert this from this to this, right? The other classical example is traffic lights. Traffic lights are the classical examples of open loop system. How are the classical examples of open loop system? Let's say you are standing in Tribune Chowk and it's a red signal towards you, right? And all the vehicles are actually waiting for that red signal to go green. But on all the three sides, there is hardly any vehicle, right? But what will happen? The traffic signals would wait for a certain set period amount of time. Only after that it would give you green signal. It will not sense the control variables. It will not sense the amount of vehicles on either of the roads, right? It has been set to a predestined amount of time for which it has to be green or for it which has to be red, right? It does not. How can we make it closed loop? Well, we can make it closed loop by having some cameras installed there, and through image processing. If the cameras through image processing would calculate the amount of vehicles standing in one of the lanes and if it is the highest number of, let's say the control logic is such design that it has the highest number of vehicles, so that side it would turn green and others will be red, right? And so on and so forth, right? Had there be a traffic policeman standing there, he would actually be using a feedback control system, right? Because he would be looking at the traffic and then taking action based on that traffic. But at present, what do we have? We have open loop control system where there is no sensing of the number of vehicles, and based on that there is no reference value based on which it would decide, right? There is only a set amount of time for which the signal remains red or signal remains green. So we have seen two examples of open loop system, and how can we convert them to closed loop systems? Closed loop control systems are also called as feedback control systems because there is a feedback taken from the system. We sense and we take that as a feedback. We'll see it in more detail in our next video.